I'm Jen.
And I'm Jason.
And we made a keyboard-driven digital synthesizer.
So first, our requirements were to have the keyboard communicate with the Nexus board through the PMOD PS2 and the UART Lite. And then we wanted to take the scan code from the keyboard and convert it to keyboard notes. And also, our last requirement was when you press a key, it shows you the note is played, and if it's one of the black keys, it'll show the flat and the sharp, and also the octave of the note played.
So for our specifications, when we started up the program, it's going to play a little jingle, and before you're able to manually play any of the notes. And we decided to use button 0 to range the octaves, to increase the octave range. So on our keyboard there's 2 ranges of octaves, and by pressing the button it will shift up by an octave. And by pressing button 2 we have a song that we preloaded into it that will play, and once the song is finished playing, it goes back into free playing mode where you can just manually input the notes you want. And on LCD we'll be able to tell you, okay, this is song playing mode and this is free play mode. And we also had a specification that when there's a key that we haven't signed, if it gets pressed, we have an error sound, and it will display as like not available on the LCD.
Okay, first is our hardware block diagram. So we just use a timer counter to keep time for our whole system, and then we have the GPIOs, the data into control, which are for the LCD initialization and printing on it, and we have the UART Lite, which is connected to 24 keys on the keyboard, and we have the LEDs, but they were only used in our testing, and we have the SPI connected to it's a DAC, which is connected to our speaker. And we have button 0 to change octaves and button 2 to play our song.
So the software diagram, it's very sequential. So we start off, we initialize the LCD, and then we tell it to free flow mode, and then we play the jingle. So after that, it just goes in infinite loop because that's all it does. So it's very sequential because we wanted to catch all the conditions possible. So first we check if there's a key has been pressed on the keyboard. Then it says, okay, if none has been pressed, it's just got to go to the next step. But if the key has been pressed, it gets a scan code, and we set a flag, so it says, okay, later on in the code, it will actually play the note. And from the scan code, we actually get, okay, where in this frequency, we have an array with like the set of frequencies in it. And it says, okay, it'll be that spot in the array to get the frequency for the note. And after that, we also check if we change the octave, if we said, okay, we want to change the octave. So if we said, yeah, we want to change the octave, we only have 3 sets of octaves, so we put a capturing condition here saying, okay, if it's over our set, then we will go to the next, we'll increment back to 0. And if it's not, then it just increments. Then we said, okay, it's going to play the song, if the button's pressed, and it will play it or not. And then the flag one is really important from up here because it will actually play our note. So play the note, it will display the note on the LCD, and it will increment this counter, because the counter is used to say how long the note will be played, which comes here, says if the counter has been exceeded for some certain value, it will say flag 0, which means turn off playing the note on the next iteration of the loop, and the counter will go back to 0. So next time if flag was 1, then we know that it will start all over again at 0, so it will count the same amount of time.
Okay, so our design overview. We just had the PS2 connector, which we had to buy separately because the Nexus 1 did not have it. And we also had we had a keyboard to use, and we had the PMOD DA2, and then we had the speaker to output our notes, and the Nexus 1 board, and our LCD screen.
For software, we had a lot of code we used when we made the function generator. We used UART, so it was able to communicate from our Nexus board, from the keyboard to the Nexus board. Then SPI, so it was able to send out our digital information to an analog. We modulated a lot of our functions because they were reused frequently. So one of them is like we had a function for just scan codes or lookup table, play song function, and show to known octave. Other examples. We use buttons for features because input output was much better than VARP. And like we had catchment conditions. That's why we, in the previous slide when we showed the software flow diagram, we had to do it all sequentially, and we were trying to find ways to make the code not work so frequently.
Okay, for integration, so the basis of our project was getting the notes. So we hooked up our Nexus board to the oscilloscope, and we had our list of frequencies we wanted. So we manually changed our bits in the actual program until we got the right frequency. And we used LEDs since our functions kept repeating over just to make sure we were hitting the right spots. And for testing, we had to just test the tone and make sure the right duration was coming out. And we had a problem with printing our text on our LCD screen, because sometimes when we input it in our code, it got caught in a loop. So it just infinitely keep printing it out over and over. So instead of getting a tone, we get like a ripple, just nonstop. So we had to work on that too.
There was one other problem we had. It was a double play on notes. So like you press the key, you would play, but when you lift the key, you have a problem. So we found out later it was because we overworked our code. It was more from the previous one how we just had repetitive code. So we found places where we could just have it only play once, so it would just like only happen once as opposed to like happening again and again and again. We also learned that the keyboard had a lot of limitations. There's a hardware thing with the keyboard where if you press a key, it would play it, like it would send out the code, but it would have a delay, and then it would go infinite. So we couldn't really have like a real holding note sound. And if we were to do this again, we'd rather make our own keyboard in the future.
Yeah. Oh, and also we would probably get a Nexus 2, and they actually sell a P-mod to headphone jack, because I know we've been here all week, and then just non-stop noise has been coming out, and everyone's trying to.
So one thing we tried to do was like we actually changed the amplitude of how loud it was going to be, so that's how we were able to like not bother you guys so much. So that's about it. Any questions? Okay, so here's our keyboard. We have our sharps and flats as the black keys, and we have 2 ranges of octaves here. Upload it. So we're going to upload our code.
I'm going to turn it on.
Power Rangers theme.
Yeah, so we're in free play mode, so you can just press any note. And then if we want to change octaves, we just press that.
So it's right on time with everything.
And then we wanted a song that would showcase all our octaves off, so
So it
and then back
goes
to free
immediately
play
back,
mode.
and you can keep
Oh,
playing.
and then if you press the wrong key.
Yeah,
Just-
it's not that obnoxious.
Yeah.
That's it.
Nice. Awesome. What are you using for your